What is up, guys? Hey Dubs here, and we are back with some more LeetCode. And well, here's the LeetCode problems. These three. Um, but if you notice here, we have 119 subscribers. Now, I didn't think I'd get to 100 subscribers in months, maybe, but I guess consistency does win. Like we're getting like 160 views on some videos. Like this one's got 98, this one's got 34, but some of them's got 300. This one's got 500. I think our first video has over 800 views, which I think is kind of crazy for YouTube. I guess the coding bros are like really intimate to and pretty loyal to low fan base. I will change the profile pic to an like generated profile pic. I just wanted to put something there, for people to look at. I guess it grabs attention somewhat. But thank y'all so much for 100 subscribers. I can't express how grateful I am for this. And not only that, 119. I mean, we got 20 subscribers in a day, which I think is awesome, guys. But I said on the 100 subscribers special, we would be doing a easy problem, a medium problem, and a hard problem. Now, I found the easy problem I want to do and the medium problem. And we're going to end with the hard problem. I did say I was going to do the, let's sort by arrays. We were going to do the in queens problem, but I don't really understand. I was looking at the solutions tab to try to figure out like what other people are doing, and it's a lot of backtracking. I mean, almost all the problems are backtracking, like a list of common backtracking problems. I'm not very familiar with the backtracking solutions, so we might have to do that later when we dive into backtracking a little bit. I did say I would try to solve it, but I was looking at the code and it made no sense to me, if I'm going to be honest. So to the commenter that asked me to solve this problem, we will get to it. I just feel like my brain is not big enough for it yet. And if you want to solve this problem, I suggest searching up backtracking problems and go through easy backtracking problems first, and then try to dip into the in queens problem, right? He said he tried to do it and it made him feel like recursion problems wasn't for him. It's not just recursion, it's a backtracking problem. So those are always hard. We're going to start with the easy problem. I already had all these solved. I did have to look for the solutions tab for not the convert, the first missing positive. Uh, but my solution, I'm pretty sure, was right, and then it wouldn't work. And I went to see what other people are doing, and I forgot to account for the negative. So I'll show you how I added that. The solution I looked at was from, yeah, from Nits. Nits is everywhere, and he does. I mean, he has videos. I would suggest checking out his channel. His is actually how to solve it, and he explains it pretty well. Mine's more like, I solved this problem, here's me solving it, and my explanations aren't very good. He has pretty well made videos with very good explanations, but he also does it in like 4 different programming languages. I'm pretty sure in his videos he usually does Python for his solutions. But today I was going to work on this video earlier, but we have some puppies that I've been taking care of. Let me go get them, see if they're up. They are snoozing. If they wake up and start making noises, like, I'll go get them. We had a big day at the park, so they are napping. It's a pretty good time to make a video. They're usually pretty loud. But I have my dog Shadow, a little Labradoodle, and then my friend Libby. She's the one that put me on the breeder, and she got her dog Iris. It's a little girl. So they're siblings, so we get to keep them together. I'm super excited about that. They love each other. They love playing together. But I have their cage blocking their way off from the couch. So they can't get out. So they've been staying in that little area all day. So I could kind of work on these problems for y'all. That's why I kind of picked some easier problems today. Like I low-key looked for the easiest hard problem I could find. I mean, if I had time today, I would do the in queens, but puppies take a lot of time and a lot of patience, let me tell you. So let's just go ahead and get started, right? We'll start with the same tree problem. Given the roots of 2 binary trees P and Q, write a function to check if they are the same or not. Two binary trees are considered the same if they are structured identically and the nodes have the same values, right? So the first thing we want to do for this problem is we want to check if either of them are null, because if the roots are null, so if p is equal to null, or q is equal to null, we want to return false. Because if either of them are null, then we're not in the node. So you can imagine we're past the root 1 and 1. If one of them are null, then we're not even past it. A tree, right? Or we want to pass and true. So if both of them are null, I think, yeah, if both of them are null, we want to return true, not false. Because if we're both past empty trees, or if we get, we're going to implement a recursive solution for this. So you can imagine that that if we check this node, they're equal, then we will see if this is equal and this is equal for both trees, right? So at any point in the program, we'll both be at one or the other. So say we're checking 2, we'll see if that's equal, and then we're going to see if left is equal and right is equal. And if both their rights and left are equal to null, then it's true, right? So we want to be sure to implement that first off. I'll just go ahead and trash that. And then I heard a puppy wake up. Oh, little baby Iris woke up. So the next thing we're going to see if P and Q are not equal to null, right? So if P is not equal to null and Q is not equal to null, and if P dot value and Q dot value, if P dot value is equal to Q dot value, then we know that this solution is true. And we want to see if is same tree, and we want to do P dot left and Q dot left. She's just walking around. She might have to use the bathroom in a minute. Is same tree P dot right and Q dot right. So what this statement is saying here, and if we break out of this, we know it's false. So return false. Playing with the little chew toys. So if we get to an end of the node, and when it calls this function for the left or the right, if both of them are null, then it's equal and we'll return true. Can y'all see baby Iris over there? Hey, buddy. Did both of y'all wake up? So I might have to, you know, do a little cut in the video and take care of the children, of course. Puppies are just baby dogs, so you got to take care of them like a baby almost. But we want to return if the left and the right is equal, and then that will recursively check both sides for the function, right? And so if they're both not equal to null, because if one's null and the other one's not null, then we know one has a node or the other one doesn't. And then if both of them are not null, we need to check if the values are equal to each other. So if they're equal to each other, then we want to go ahead and check the left side and the right side of the node. And then if the left or right is null and both of them are null, it'll return true to the function. And then if if for any reason the values aren't equal, or if one of them aren't null and the other one is, it will return false. And if we go ahead and run that, there we go. They're true for the first case, and then the second one, it's false. The reason it's false is because it sees that the first one's not null, so then it goes to the if statement, and if P is not null and Q is not null, which they're not, and then the P and Q values are equal to each other, we'll return the same tree, return if the function call for the left and the right node also return true. So for the left node, it will get the left side of both of these. So you can see one is pointing to null, and then one is pointing to 2 on the left side. And then it will see that if P is equal to null and Q is equal to null, so that means we're at the end, it will return true. But they're not, one of them is a node. So then we check if both are actual nodes. And we can see here that the left side of the, what would be the Q node, the Q tree is not null, or it is null. So it breaks out of the statement and it returns false, and then that gets returned false, and then the right side also gets returned false. But since one returns false, both will return false, and that would return the false all the way to the top, right? So if there's one instance where neither of them are true or equal to each other, then it will return false for everything, because is same tree and is same tree gets called on the left and right node recursively for all values. And we can go ahead and submit this and see what the time complexity is. It goes 0 milliseconds. And that one's not too bad. It's just a recursive call. Basically, this would return true, because if they're both at a null node, then we know we've made it to the end of that side of the tree. And then if once we make it to the end to the right side, like it will just return null once we get to the past the leaf nodes of every tree. And then while it's checking each node on the way, it'll make sure that one doesn't have a node and the other doesn't have a node. And then if they both have a node at the same spot, then it'll say if the values are equal to each other. And if they're equal to each other, we'll run the same function on the left and the right nodes. So the space complexity would be, it would be n, where n is the side of the size of the tree. And then the time complexity is n as well, where n runs this function for every node in the tree. So I'm pretty sure the space and time is n. But yeah, this solution isn't too bad. And then this one is a bit more complicated. I feel like this one is more complicated than the missing positives. Yeah, first missing positives. We'll go ahead and pull this up right here. Oh, the solution came out. Okay. So what we want to do is we want to find the median, because it's already a sorted linked list. We want to find the median, store that as the root node, and then break the list up into the right and the left side. And then the left side of the tree will store these two values, and the right side of the tree will store these two values. And we'll do that over and over for the entire tree, right? So first thing we want to do is see if the head is equal to null. If that's the case, we'll return null. And then if the head dot next is equal to null, then we know there's no node, because if you can imagine, a single value list is the only node if it points to null. There's no nodes that will be under it, so we can go ahead and make this a tree node by itself and make it point to nothing. And so we want to return a new tree node, head dot. And then the next thing we want to do is we want to find the median of the list, right? So we'll do a list node previous, and we'll set that equal to null. list node current, and that'll be equal to head. We'll do slow. Slow is equal to head. Who is playing with the piggy? Okay, this is a good time to take a break because I'm gonna take the loud toys away from them because that piggy is. What are you doing? Wait. Here are the puppies. I don't know if y'all can see them. So this is the runt baby, and then this is the biggest boy. I'll give them that toy back at the video because just for y'all's ears, hopefully y'all don't hear that. And then we'll do a list node, node to fast. That's going to be equal to head as well. And then while I think it's fast, it's not equal null. And fast dot next does not equal null. The reason we're checking both of them because the fast node is going to go 2 of head, and then the slow node is going to go 1 ahead. So we'll set previous equal to slow, and then slow equal to slow dot next. And then we'll see fast is equal to fast dot next dot next. So if you we have the slow and we have the fast node. In the first iteration, slow will go 1, and then fast will go 2. So fast will be here at 0, and then slow will be here. And slow will always find the median as soon as it breaks out of the while loop, because you can imagine the next iteration and the previous will be set to this node. And then fast will be dot next. So fast will find the end, and then slow will be set to the next, and then previous will be set behind it. And then fast will be check its next, and the dot next is equal to null. So we know we found the median, and then we'll store the 0 into the linked list. And then we'll set the previous dot next equal to null. So we'll break this link and set that equal to null. And then when we want to check this, the rest of this linked list, so the 5 and the 4, we'll do a slow dot next. So we'll be sure to get the 0 value. And then we'll do the, we'll create a node, a tree node. And we'll do tree node dot left and pass it this linked list. And we'll recursively call the left, and then we'll do the same for the right and pass it this linked list. That's a lot of mumbo jumbo, but we'll go ahead and type this up. So all this is doing is finding the median for us, and then we'll create a new tree node. I'm just gonna call it node, and set that equal to new tree node, and we'll set it to slow dot value. You can see them playing in the little kennel. Shadow, be nice to your sibling. She's a lot smaller than you. And then we'll set the previous dot next equal to null. Like we said earlier, we want to make sure to pass just this value. And then we'll do node dot left is equal to what is it? Sorted list to binary search tree, and we'll pass it the head that we were given because that's still pointing to 10. And then node dot right will be all the greater values. So once we find the median, since this is a sorted list, we know everything. So head is still here, and then slow is at 0. We broke this link, and now it's pointing to null. Calm down, guys. So when fast iterates through this part of the list, it will stop here, and then the slow should be at 3. And then for this value, this is pointing to null. And we're going to pass slow.next. So we're going to pass these two nodes, linked list, into the right. So sorted list to binary search tree, and we'll do slow.next. And then after all that, we'll go ahead and return the node itself, because this will recursively add up all the values. And we can go ahead and so slow.next. And if there's a single value, so once we add the 9 and the 3 into our binary tree, 10 will be pointing to null, and so will the 5. So we can see that there's no other value to add into the list once we break it. So this is kind of like a divide and conquer question as well. So we'll just go ahead and return that tree node as itself, because that's going to be the leaf of the binary search tree. And then when we return the node, it will slowly build the tree all the way back up, because the dot left will have the tree and the dot right will have the tree that we built under it. So we'll recursively build it node by node, because at the very end, the last function call will have 5 and 10 as a node, and then it will return the dot left here, and there's nothing to return to the dot right, and then it's nothing to return to the dot right. So then then once those get passed back, it will have this tree, and it will return this null to this dot's left, and then this node to this dot's right. And then the 0 head node will finally get returned at the very end, and then that returns the entire tree that we just built. Go ahead and run this. I'll get accepted for those, and we'll see what it does in the submit. There you go. 0 milliseconds beats 100%. And that is Shadow. You can't keep your eyes up with them. Let me check on them real quick. I'll be right back. Yeah, pull it off. You pulled the rotor remote off. Don't want them chewing up the TV remote. Today's a pretty rough day to have the 100 subscriber special, because not only, I don't know if y'all heard me, today's a rough day to have the 100 subscriber special, because not only do I have one puppy, I have 2 puppies to deal with today. But we're going to get this video recorded for y'all. So the next problem is the first missing positive. So given an unsorted integer array nums, return the smallest positive integer that represents this. Return the smallest positive integer that is not present in the nums. You must implement an algorithm that runs in 0 in time and uses O of 1 auxiliary space. Okay, so we don't want they don't want us to create anything dynamic. So we don't want to push like all these values into a list or something or a stack. So if we create a variable, it needs to be one variable, and it doesn't need to grow or shrink based on our input size. And it wants us to go through the list one time. So input is nums 1 to 0. We want to return 3. The number in the range 1 to 2 are all in the array. So we return the 3 because it wants us to return the smallest positive integer that's not in the array. So that would be 1, then 2, and the next one we want to find is 3. And then for this one, we have the 1, we have a 3 and a 4, and 2 is missing, so we can return 2, because that's the smallest positive number that's not in the array. And then for the final one, there is 7, 8, 9, 11, and 12. 1 is the smallest positive integer that's missing. So this one's not too bad. The first thing we want to do is sort the array. So arrays dot sort, and then we want to pass in the nums. And this will give us a value from all the negatives to the positives. And then for int I, so we're gonna store the positive index. Positive I is equal to 0. For I is equal to 0, I is less than nums.length. And we'll do I plus plus. If the nums at I is greater than 0, then we know that that is the index, the starting index of the positive numbers, right? So that means that we have iterated through all the negative numbers, and then the positive indexes are now at I. If it goes into this while loop, and then we want to go ahead and break, because that's all we wanted to find was the positive values. And then the next thing we'll search for is the actual, what is it, min positive. So we'll do integer min positive is equal to 1. Because 0 is not a positive, that's a non-negative and a non-positive number. So we want to find positive numbers, and then so at the end we'll want to return our min positive. So return min positive. So for int I is equal to positive I is less than nums dot length, and I plus plus. And inside of here we want to see if the current value of nums is if nums dot length, not nums dot length, if the number at I, because you gotta remember we just sorted the list, and so the first positive value, if it's it will be the smallest positive value that we're looking at currently in the list. If it's equal to 1 for the first iteration, so we want to see if it's equal to min positive. So if it's equal to the minimum positive, the next minimum positive we can possibly look for is 2. So we can go ahead and set min positive equal to plus plus, because the next value we're going to look for in the list is 2. And if we find 2, then we're going to look for 3. And if we find 3, we're going to look for 4. And so on and so forth until we find a positive number that's not in the list. Hey, y'all calm down. They're being feisty. So next thing we're going to see is the else if. And the reason we're doing an else if is because there can be repeat numbers, right? So you could have 2 1 values, and then if we're looking for 2 and there's another 1, we don't want to return 1 or 2 even though we haven't checked for the 2. So else if, we want to see if nums of I is greater than min positive, right? So if the next number we look at is greater than the minimum positive we have and we're looking for, then we know that the minimum positive is not in the array because it's sorted, right? So if the next number we look at is greater than it, then there's no value that is our minimum positive. So we can go ahead and return the min positive. And then if we iterate through the entire list and it's like a subsequent array, like 1, 2, 3, 4, 5, 6, like in this case, it will we'll be given index 1, and we'll look at 1. Once we find that 1's not in the array, we'll increment it by 2, by 1, not 2, and then we'll be looking for a minimum positive of 2, and then we'll see that nums of I is equal to 2, and then we'll increment it again, and then we'll go back through the for loop, and since we've made it to the end of the list, we'll break out, and the minimum positive is 3. Kind of fast explanation because the puppies are going crazy. See, that works for that case. Go, and if we go ahead and submit this, this should be a valid solution. It's not the quickest solution by all means. You see it runs in 14 milliseconds. The other one I submitted 32 minutes ago was 18 milliseconds, so this one's actually quicker. I thought it was 13 milliseconds. Anyways, that's like, it beats 24%. Most of them run in 1 millisecond. We're not going to review any other solutions because I was trying to get this video out while having the puppies to deal with. So I'm about to go check on them, make sure they haven't pissed or shit anywhere. And then I just want to say thank you again for all of the support. Let's see if we've gained another subscriber. No, we're still at 119. So I'm going to post this video tonight. I hope y'all have been enjoying this journey I've been on, because I've thoroughly been enjoying it. I've been learning a lot while going through it. Day 1 over 2 weeks ago, and now we're on day 18. That's a big step. We're going to try to make it to a month, and after that we're going to try to make it to a year, and after that until I get a job, right? So hope y'all enjoyed this video. Be sure to leave a like and a subscribe, and y'all stay healthy, y'all stay blessed, and I will catch y'all in the next video. And be sure to keep coding. Of course, just stay coding. Why wouldn't we? ChatGPT is not going to take all of our jobs in the future. Every developer's cooked. I'm not going to lie. But that's why I'm trying to do this. Get myself ahead of the average Joe, right? Maybe I can pass an interview if I even get one. I mean, you can apply to 1,500 job applications and they won't even look at you at this point, right? Because they're looking for the senior devs that's been working 30 plus years that can decode the gibberish that ChatGPT spits out at this point. But anyways, still, I love computing, I love coding, so that's what I'm gonna do. And I hope y'all enjoy this video. Thank you for 100 subscribers again. Next up is probably going to be 250 and then 500. And yeah, I hope y'all enjoyed the easy, medium, and hard step up ladder we did today. I did a very easy hard problem. Of all the hard problems I probably looked at 30 for an hour, and I didn't think I could solve them in a good amount of time, and I don't think I could have come up with a solution within an hour. I would have to look at those problems for like 2-3 hours before even coming up with anything. Without looking at looking at the solutions tabs for some of them, you're just like, it was like gibberish. It would take me a while to even decipher it and understand it. And that's the main point. Even if you look at the solutions tab for a problem, I mean, yeah, you're copying code. I feel like it's better if you're, with time, you'll be able to solve the problems by yourself, especially if you understand the problem space and a lot about the objects you're working with. But if you do look at the solutions, I wouldn't feel too bad. As long as you understand what you're looking at and take it in, then you'll be able to solve problems that are similar to it with very like what is it? The best solution code. I mean, it's called the best solution for a reason, right? It's the best time, it's the best space, and that's what you want to do. You want to have the best time and space. And if you can't come up with that by yourself, at least understand how you get to that point. And that's probably the biggest lesson I have taken away from doing LeetCode for 19 days now. Along with doing schoolwork, school is kicking my butt. I have 2 tests the Tuesday that I haven't studied for, and I have a 6-page paper, rough draft due Thursday. So I gotta be sure to work on that. Off Monday, I'll do another LeetCode video. I might try to do a medium or a hard problem. But I'll probably do an easy problem tomorrow because I work in the morning, afternoon, and my girlfriend are off. I'm gonna try to spend a little bit of time with her and work on some other schoolwork. And then Monday's gonna be a big study day for my 2 tests Tuesday. And then I also need to start working on my paper, and I'll need to work on my paper Tuesday night, and then Wednesday night, and then Thursday night. So all 3 of those nights I'll have to be grinding and typing away. I'm going to try to get at least 2 to 3 pages done on that thing. And I'll probably share the paper on here because it will be over a programming language. I'm studying Go. I'm comparing concurrency with Go with C++ and Java, with its complexity, how it does with space, and how easy it is, and how safe it is. So just kind of comparing all the aspects about it, and what Go does well with concurrency, because that's what it's known for, is being able to run concurrency fairly well. But anyways, I'm kind of rambling here. I'm gonna let y'all go now. Y'all stay coding, stay healthy, stay blessed, and I'll catch y'all in the next video. Hey devs, it's out. Where is the stop button?